So P6.6 continued, and the only thing that I want to talk to you about, which I didn't mention in the last one, was an experiment that you can do where what you want to do is you want to measure the pressure in a gas and you want to change the temperature. Okay, and if you do that, you end up with a graph that looks like this. So if this one is pressure and this one is temperature. Now, you have to be very careful to make sure that you control the volume. And you need to control the number of particles as well. So volume and number of particles must stay the same. But what you're doing is you're changing the temperature and you're measuring what effect that would have on pressure if you keep these two the same. Okay, they're your major control variables in this one. Okay, and then you notice this line here, and you can see that's a nice straight line graph. Okay, but even more interesting than this is this bit here is 0 degrees Celsius, but that's not at zero pressure. Okay, so what they said was, well, what happens if you keep decreasing the temperature until you get 0 pressure? So the point where you get 0 pressure would be here, and that is at minus 273 degrees Celsius, or better known as 0 Kelvin, and that is known as absolute zero. And the reason why it's absolute zero is because the pressure is zero and you can't get less than 0 pressure. And just did that simply by measuring the pressure of a gas by changing the temperature, you can work out the fact that there is a temperature at which you cannot get colder than. And space, which is about the coldest thing we can see, is around about 2 Kelvin. So later on you're going to find out, where does that 2 Kelvin come from? Why is it not 0 Kelvin?